I'm going to show you how to take a curl of a vector field. We have a given vector field here and we'd like to find the curl. The curl definition is awkward. It's hard to remember, it's difficult. This is how people typically deal with curl. So here's the thing we saw from the definition. I'm putting these pieces together in a matrix, and a matrix is just a box full of numbers, or in this case functions, and we have our standard unit basis vectors here on the first row. On the second row we have these things that aren't derivatives of anything, but they're going to be operators, and they're going to operate on the functions in the third row by taking the appropriate derivatives of those functions. So what we do is called a determinant. It's something we learn about in linear algebra. We'll just deal with here a little bit. First I'm going to go down this row like so. And I'm going to say, okay, that's an I, and I have a partial derivative with respect to y of negative y squared. So that's negative 2y is that partial derivative. And then the other piece that I'll get with a y, so we had a negative 2y. The other piece I'll get with a y is if I go kind of that way. And I have three terms every time, and that's how you remember kind of how to piece things together here. But here I'm saying, okay, the z derivative of xyz, and when I'm going to the left I take the negative of the term. So it's negative xy. Okay? Oops. All right, so I can't seem to erase everything I wanted to. There we go. There's the pieces back together again. Now, that's the I term. So for the j, we do a negative on the j, and it's always I positive, j negative, k positive. So this is how it goes. And with the j, we're going to go to the right. Again, we'll get three terms. So that's going to be a z derivative of xz, and the z derivative of xz is just x. And then we'll go, so we have the x, and then we'll go to the left and get three terms. The x derivative of y squared is 0, so that'll be a minus 0. Plus the k, so for k to the right, three terms, it's going to be the x derivative of xyz, which is just yz, minus the y derivative of xz, which is a 0. Putting all that together gives us the curl of our vector field. Our x component is minus 2y minus xy. The j component is negative x. Remember, I have that negative on the j out front. And the k component is yz. This is the curl of our vector field. It is itself a vector field. Right? That will always be the case, but that's the curl of the vector field, and it's done in this way. Let me show you again kind of the pattern. For I, we start by going to the right. We then go to the left. For j, to the right. J to the left. K to the right. K to the left. When we go to the left, we're taking the negative. And then the only other thing to remember is that it goes positive I, negative j, positive k as we do this. So that's a pretty easy way to remember how to find the curl, and it doesn't involve memorizing the definition of the curl, and we get, of course, the right answer for the curl at the end.